What if everything you think you know about the sun is just the surface of something far more extreme? Because right now, above your head, there is a system so powerful that it takes light more than 100,000 years to escape its core, and then just 8 minutes to hit your skin. That same light you see every morning is older than the pyramids of Egypt, older than recorded human history, older than almost everything we can imagine from Earth. And here's the shocking part: that light didn't even start at the surface of the sun. It began deep inside a chaotic nuclear furnace that NASA is only now beginning to truly understand. What NASA found about the sun doesn't just explain how it works, it completely changes how you understand life, energy, and even your own existence. Everything starts with nothing. A massive, empty cloud of gas drifting through space. Some of these clouds stretch across hundreds of light years. They are not small, not simple, and not stable. They are the raw material of entire star systems. But where did this material come from? To understand that, we have to go back billions of years. After the Big Bang, the universe was filled mostly with hydrogen and helium. But over time, stars lived, burned, and died. When they exploded as supernovae, they scattered heavier elements across space. Oxygen, carbon, iron, everything was blasted outward and mixed into these enormous clouds. So in a very real sense, the sun is not original. It is recycled stardust. Over millions and even billions of years, gravity begins to pull that dust and gas together. Tiny clumps form first, then larger ones. The more mass they collect, the stronger their gravity becomes, pulling in even more material. Eventually, something massive happens. A nearby star explodes in a supernova, sending a shockwave across space. That shockwave compresses shapes of the cloud like a giant cosmic push. And once that happens, gravity takes over completely. Dense regions begin collapsing inward, heating up, and spinning faster as they shrink. These regions become what scientists call protostellar cores. At this stage, there is no light, just a massive, dark, spinning ball of gas larger than our entire solar system, slowly pulling itself tighter and tighter under its own gravity. Inside this collapsing core, pressure and temperature keep rising. Gas particles crash into each other faster and faster, and as they collide, they generate heat. Then, something critical happens. Around 10 million degrees Celsius, the core reaches a tipping point. Hydrogen atoms begin to fuse together. This is nuclear fusion, and this is the moment a star is born. When hydrogen nuclei fuse, they form new elements and release enormous amounts of energy. Suddenly, the collapsing object is no longer just being crushed by gravity. It's fighting back. Light is born. The protostar becomes a true star. Our sun turns on. But that's not the end of the story. It's just the beginning. As the young sun forms, it begins to spin. And that rotation changes everything around it. Not all the gas falls into the center. Instead, the spinning motion flattens the remaining material into a wide rotating disk. That disk becomes the birthplace of everything else in our solar system. Planets, moons, asteroids, comets, all formed from that same spinning cloud. But even then, the sun is not yet stable enough to support life. Deep inside its core lies the most extreme environment we know of. Temperatures reach about 15 million degrees Celsius. The pressure is so intense it is roughly 250 billion times stronger than Earth's ocean floor. At this depth, matter behaves in a completely different way. Atoms are ripped apart, electrons are freed, and the entire core becomes a superheated electrically charged soup known as plasma, the fourth state of matter. This is not solid, not liquid, not gas. This is something else entirely. Inside this plasma, hydrogen nuclei continue to fuse in a chain reaction called the proton-proton chain. It begins with simple hydrogen atoms, each containing a single proton. Under normal conditions, these protons would repel each other like identical magnetic poles. But inside the Sun's core, the pressure is so extreme that they are forced together anyway. Hydrogen becomes deuterium, then helium-3, then helium-4. Step by step, hydrogen is transformed into helium. And in the process, energy is released. But here's the twist that changes everything. The final helium atom weighs slightly less than the original hydrogen atoms combined. That missing mass doesn't vanish. It becomes energy. This is Einstein's equation in action. Mass turns into energy, and the scale of it is unimaginable. Every single second, the Sun converts about 4.3 million tons of mass into pure energy. That's like millions of cars disappearing into energy every second without stopping. But the Sun doesn't explode from this power. Instead, it reaches balance. A perfect equilibrium called hydrostatic balance. Gravity pulls inward, energy pushes outward, and for now, they cancel each other out perfectly. That balance is what keeps the Sun stable for billions of years. Now here's where things get even more surprising. You might think the light created in the core shoots straight into space. It doesn't. It takes an almost unbelievable journey. Once energy is produced in the core, it becomes photons, particles of light. But inside the Sun, space is not empty. It is incredibly dense. So dense that a photon cannot travel in a straight line. Instead, it gets trapped in a chaotic maze. It moves a few millimeters, crashes into another particle, gets absorbed, then re-emitted in a different direction. Then it happens again, and again, and again. This process is so random that scientists compare it to trying to walk blindfolded through a crowded city where every step sends you bouncing in a new direction. This is known as random walk behavior, or more scientifically, a diffusion process similar to Brownian motion. And the result is shocking. Instead of taking minutes, or hours, or even years, it takes photons somewhere between 10,000 and 170,000 years just to escape the Sun's interior. Think about that. The light hitting your face right now may have started its journey when early human civilizations didn't even exist. As photons slowly migrate outward, they lose energy. Deep inside the Sun, they begin as extremely high-energy radiation, including X-rays and ultraviolet light. But after thousands of years of bouncing around, they cool down. By the time they reach the surface, they finally become the visible light we see, the warm sunlight that makes life on Earth possible. And then, in just 8 minutes, that light travels from the Sun to Earth, from the surface of a star to your eyes, almost instantly. That is the final leap of a journey that began deep in a nuclear furnace millions of years ago. So the next time you step outside and feel sunlight on your skin, remember this: you are not just feeling warmth. You are touching energy that was born in a collapsing cloud of stardust, transformed in a fusion engine at 15 million degrees, trapped for thousands of years inside a dense plasma prison, and finally released across space just to reach you. And this is only what we understand so far. NASA continues to study the Sun using advanced spacecraft and solar missions, uncovering more about its magnetic storms, plasma behavior, and hidden dynamics every year. But one truth is already clear. The Sun is not just a burning ball in the sky. It is a living system of physics, time, and energy, on a scale that reshapes how we see everything. And the most powerful part? It's the reason we are here at all. If you enjoyed this journey into the hidden life of the Sun, make sure to like the video and subscribe for more deep dives into the mysteries of space, science, and the universe we live in.